So the last thing in osmosis we have to discuss about the reverse osmosis. From today's onwards we are discussing about this osmosis concept. In the first class I explained you what is osmosis, what is osmotic pressure, and what is semi-permeable membrane. I explained you about these things in the first class. In the second class I explained you about different kind of solutions, like we can say isotonic, hypotonic, hypertonic solutions. Regarding these solutions I explained in the previous class. In today's class we shall discuss about the last one more concept in osmosis. We shall discuss about the reverse osmosis concept. We shall discuss about the concept of what means reverse osmosis. What do you mean by this reverse osmosis means? What do you mean by this reverse osmosis means? Generally, you know, in osmosis concept, the solvent is flowing from generally we know that in osmosis concept, the solvent is flowing from pure solvent to solution. The solvent is flowing from pure solvent to solution. Generally, the concept of osmosis, we know that the solvent is flowing from where to where means pure solvent to solution through a semi-permeable membrane. The solvent is flowing. Now, if you exert some pressure here, if you are applying some pressure here, by applying how much amount of pressure on solution side? By applying how much pressure or how much amount of pressure on solution side, the flowing of solvent will be stopped. Is called as what means osmotic pressure. We should call what we should call means osmotic pressure. Osmotic pressure is nothing but the pressure exerted on solution, the pressure applied on solution side to stop the flow of solvent through semi-permeable membrane is called as what means osmotic pressure. Osmotic pressure andre solution ಮೇಲೆ ಎಷ್ಟು pressure apply ಮಾಡಿದ್ರೆ flowing of solvent ಅನ್ನೋದು stop ಆಗುತ್ತೋ that pressure we are calling as what means osmotic pressure. Now we are discussing about reverse osmosis. What do you mean by this reverse osmosis means? If the pressure applied on the solution side, if the pressure applied on the solution side is more than the osmotic pressure, when the reverse osmosis takes place means if the pressure applied on the solution side, if the pressure applied on solution is more than the osmotic pressure, more than the osmotic pressure, then osmosis takes place in the reverse direction. Reverse direction is what we can say. Now the pure solvent will flow from solution to solvent. And actually in osmosis the solvent is flowing from solvent to solution, but here the solvent will flow from solution to solvent. Solution to solvent is called as what means reverse osmosis. We should call it. What we should call it means reverse osmosis. When only reverse osmosis will occur means if the pressure applied on solution is more than the osmotic pressure, if the pressure applied on solution is more than the osmotic pressure, then only reverse osmosis will take place. Then in such a case what will happen is the solvent is flowing from solution to solvent. The solvent is flowing from, the pure solvent is flowing from solution to solvent through semi-permeable membrane. This technique is called as what means reverse osmosis we are calling it. What we are calling it means reverse osmosis. What is the application of reverse osmosis? Where it is used in, especially this reverse osmosis technique. This reverse osmosis technique is especially used in the desalination of seawater, especially used during the desalination of seawater. So we take in here seawater. We take in here water, no seawater. You know that seawater contains salt in it. Seawater contains salt in it. So seawater contains salt in it. Now if you apply the pressure, which is more than the osmotic pressure, if you are applying pressure on the solution side which is more than the osmotic pressure, then what is happening from the from the salt water, from the seawater, the water will come outside. Reverse osmosis is taking place. What is taking place here means reverse osmosis is taking place. If the pressure applied on the solution is more than the osmotic pressure, reverse osmosis taking place. Osmosis taking place in opposite direction. Opposite direction means the pure solvent will flowing from now solution to solvent. Actually, we are taking a seawater. Seawater means nothing but salt water. Salt and water is there. Now, among the salt and water, all the water is coming outside. What is left here means only salt is left here. So, this technique is called as what means reverse osmosis. Reverse osmosis, where it is used in means especially reverse osmosis technique is used in case of desalination of salt water, or we can say desalination of seawater. Okay, from seawater, if you want to remove the salt, okay, we have to use this technique of what means reverse osmosis. Okay, we take in seawater here. If you apply the pressure more than the osmotic pressure, then salt will be remain here only. All the water will come out. This will come into this chamber. So this technique is called as what means reverse osmosis. We are calling. What we are calling means reverse osmosis. And one more point, students, here. While doing this reverse osmosis technique, the semi-permeable membrane is made up of what means cellulose acetate, we can say. While doing the reverse osmosis technique, the semi-permeable membrane is made up of what means cellulose acetate. So this is about what means reverse osmosis and its application. So how can you define this reverse osmosis means, students? If the pressure applied on solution is more than the osmotic pressure, then pure solvent flows from solution to solvent. The pure solvent is flowing from where to where means solution to solvent. The pure solvent flows out from solution is called as what means reverse osmosis. We are calling. What we are calling it means reverse osmosis. If the pressure applied on solution is more than the osmotic pressure, then pure solvent flows out from solution. This technique is called as what means reverse osmosis. We should call it. What we should call it means reverse osmosis. Where you are using this, especially reverse osmosis technique means reverse osmosis technique is especially used in desalination of seawater. From the seawater, if you want to separate the salt and water separately, compulsory we have to follow the technique of what means reverse osmosis. Along with this one, in the purification of drinking water also, we are using this reverse osmosis technique. In your home, you are having the water purifier. In every water purifier, it will be mentioned RO. RO means reverse osmosis. The water is purified by using the technique of what means reverse osmosis. Okay, while doing the reverse osmosis technique, the semi-permeable membrane is to be made up of what means cellulose acetate. So this is about the last concept in osmotic pressure, that is reverse osmosis. Okay. Now we shall discuss some numerical problems on this osmotic pressure. By with that we shall complete this colligative property of osmotic pressure. We shall do some numericals. Okay, textbook numericals based on the osmotic pressure. Okay. First question we are doing here. Page number 54 in the textbook. Example 2.11. Page number 54. Example 2.11. 200 ml of solution contains how many grams of protein? Means 1.26 grams of protein. 200 ml of solution containing 1.26 grams of protein. How much of solution is 200 ml? I already said you in previous class also, When you are doing the osmotic pressure related problems, compulsory volume of solution is to be taken in liters. So 200 ml means how many liters it is? 0.2 liters. 0.2 liters. Next, temperature. Temperature how much given means 300 kelvins is given. Temperature given 300 kelvins. Osmotic pressure pi is equal to osmotic pressure pi is equal to 2.57 into 10 power minus 3 bar. Osmotic pressure pi is equal to 2.57 into 10 power minus 3 bar. We have to calculate the molar mass of protein. What we should calculate means molar mass of protein. Small m, we have to calculate what is small. Can you tell me what is the osmotic pressure formula? What is the formula of osmotic pressure we are having means pi is equal to WRT by m into V. Pi is equal to WRT by m into V. It is the formula for what means osmotic pressure. Pi is equal to WRT by m into V. Weight of protein how much given means 1.26 given. R value, okay, since pi value is given in bar, R value also we have taken the bar. What is R value in bars? We can say 0.083, that we can write it as 8.3 into 10 power minus 2. Temperature how much means 300 kelvins. 3 into 10 power 2. 3 into 10 power 2. Molecular weight we don't know. We have to find out what means molecular weight. Osmotic pressure how much given means 2.57 into 10 power minus 3. And volume of solution how much given means 0.2 liters. That you can write it as 2 into 10 power minus 1. 2 into 10 power minus 1. Okay. So minus 2 plus 2 both will be what happened means cancel. Minus 2 plus 2 both are cancelled. Therefore m is equal to what we are getting here 1.26 into 3 into 8.3, it is 24.9. 24.9 means approximately we can write it as 25 by 2.57 into 2. 2.57 into 2 means 5.14. 5.14 into 10 power 4. 5.14 into 10 power 4. If you make this calculation, how much we are getting? The answer means 61.2 we are getting. What we are getting is 61.2. So 61.2 into 10 power 4 grams per mole. It is the answer we are getting. Okay, 61.2 into 10 power 4 grams per mole. It is the molecular mass of protein we got in this question. Okay, so this is about the first question. Example number 2.11 we completed. Next we shall discuss about the in-text question in that next page only, page number 55. Example number, question number 2.12. Question number 2.12. Question number 2.12 we shall discuss. Question number 2.12, what is given means calculate the osmotic pressure in Pascal. Calculate the osmotic pressure in Pascal exerted by a solution by dissolving 1 gram of polymer. 1 gram of polymer. Weight of substance how much given means 1 gram is given. Weight of substance 1 gram is given. Molecular mass 1,85,000. 1,85,000. Volume 450 ml. That is nothing but 0.45 liter. Next, temperature 310 Kelvin. Temperature how much Kelvin means 310 Kelvin. We have to find out what means osmotic pressure. We need to find out. What we need to find out means osmotic pressure. So remember students, R value in Pascal. R value in Pascal is how much means 8.314 into 10 power 3. R value in Pascal. Okay, how much means 8.314 into 10 power 3. Pascal mole inverse Kelvin inverse. Pascal mole inverse Kelvin inverse. We have to calculate what means osmotic pressure. Directly you can apply the formula. What is the formula we have? pi is equal to WRT by m into V. Pi is equal to WRT by m into V. Weight of substance 1 and R value 8.314 into 10 power 3. Temperature how much is 310 divided by molecular mass. Molecular mass 1,85,000. 185 into 10 power 3. 185 into 10 power 3 volume. Volume of solution how much means 0.45 liters. 0.45 liters. 10 power 3, 10 power 3. Both will be cancelled. 10 power 3, 10 power 3. Both are what happening means cancelled. Okay. So 10 power 3, 10 power 3 both are cancelled. You can make this calculation of 8.314 into 310. 8.314 into 310, how much we are getting is 2577.34 divided by 185 into 0.45, we are getting 83.25. 83.25. If you make this calculation, what is the osmotic pressure we are getting is 30.95 pascal we are getting. What is the osmotic pressure we are getting is 30.95 pascal. Okay, these are the numerical problems basing upon what means osmotic pressure. 30.95 pascal we are getting. Okay, next. One more last problem is there. We shall discuss that one also. Page number 61. Page number 61. Question number 2.22 we can see. Page number 61, question number 2.22. What is given means at 300 Kelvin, 30 grams of glucose present in 1 liter of its solution. 36 grams of glucose present in 1 liter of its solution, having osmotic pressure of 4.98 bar. 4.98 bar. Okay, if so this is clearly given here at 300 Kelvin temperature. 36 grams of glucose present in 1 liter of its solution, having osmotic pressure of how much means 4.98 bar. If osmotic pressure is 1.52 bar, what will be its concentration? What will be its concentration? We know that clearly that osmotic pressure is directly proportional to what we know concentration. Osmotic pressure is directly proportional to concentration. So first of all, calculate the concentration. So they give me 36 grams of glucose. For osmotic pressure, which method of concentration we shall use means molarity we shall use. What we shall use means molarity. So 36 weight by molecular weight into 1 by volume of solution liters. 1 by volume of solution liters. So 36 by 180. 36 by 180 means it is 1 by 5. 1 by 5 means how much means 0.2. So osmotic pressure is directly proportional to what means concentration. So we can apply this formula. Pi 1 by pi 2 is equal to C1 by C2. They given clearly in the question, for 36 grams of glucose present in 1 liter of solution, they are having osmotic pressure of how much means 4.98 bar. 4.98 bar. So 4.98, when for osmotic pressure is 4.98, concentration is how much? 0.2. What will be the osmotic pressure? Okay, what will be the concentration? What will be the concentration when osmotic pressure is 1.52? What will be the concentration when osmotic pressure is 1.52? That's what they asked in the question. What will be the concentration when osmotic pressure is what means 1.5? So we can calculate C2 here. C2 is equal to 1.52 into 0.2 divided by 4.98. Cross multiplication 1.52 into 0.2 divided by what means 4.98. If you make this calculation, you are getting how much means 0.06 we are getting 0.061. Concentration, that means nothing but moles per liter. It is the concentration we are getting for this one. Okay, when osmotic pressure is 1.52, how much concentration we are getting means 0.061 moles per liter. It is the concentration we are getting. So these are the numericals present in, basing upon the osmotic pressure in our textbook is there. So with this we complete about the 4 colligative properties. We have completed our discussion. Last one more topic is left in the solutions lesson. We have to discuss about the abnormal molar mass. Abnormal molar mass. Okay. Regarding that, we shall discuss in the next class. Okay. Thank you.